So who's going to be our next generation of innovators? The traditional model, kids go to school, they learn something, a little math and science, they grow up, and maybe they'll invent something. Well, the Center for STEM Education at UCCS, we think that we need to reverse that order, that kids need to invent in order to learn. The key to engaging a child in STEM is to put them in the role of maker, not just a tech user. A quick history lesson shows us that this must be our first point of change. There is a common theme among the Sputnik generation. They built stuff. They were makers. We must create makers who evolve into scientists and engineers, not the other way around. One possibility to do this exists in the form of a physical computing platform called Arduino. In the remaining time, I'll tell you about Arduino and how we're going to use it to create tech makers. Arduino is a programmable microcontroller board, essentially a low-power computer, which allows makers to build devices that can interact with their environment through sensors, using an open-source C++-based software. This is what we call physical computing. We're doing this by explicitly answering the "so what, who cares about this" question that all students ask. This is done by using a framework of tech that helps people, community, and the environment. This framework better engages girls and the non-STEMmy kids by providing a practical context to use the technology. Let me tell you two stories. Jasmine was forced to come to one of our engineering camps by her parents. Every time she was asked about her future career aspirations, she stated that she was going to move to California to become a hairstylist. After brainstorming with Jasmine's all-girls team, they chose a tech that helps communities. They observed that community gardens start well but go untended. Could a robot be designed that would keep a community garden watered? This all-female team designed, built, and programmed a working prototype, a robot that could detect levels of humidity and respond to these data by turning on an LED. This all-female team of high school students, one of whom wanted to be a cosmetologist, found a real-world problem, built and programmed a working prototype in 1 week with materials costing less than $100. My second story. We had a mixed gender group of 6th through 8th graders from Harrison School District 2. After some instruction, they chose Arduino to do a tech that helps people. Could a device be built to help a senior citizen manage their food pantry? After some brainstorming, the students decided to tape a small pressure sensor onto a shelf. Cans were placed on the sensor. When the last can was removed, a buzzer sounded. So, a group of mixed-gender, ethnically diverse middle school students from an underperforming school district designed a tech application for a real-world problem, built a working prototype, and programmed this prototype. We currently have 11 rural schools that are doing the same, brainstorming, proposing, and building their own projects using this Arduino platform. What is the return on this investment? With an affordable equipment entry point of about $40 and free, non-proprietary open source software, the return is endless. Students quickly become makers in their own unique projects. Students experience robust failure, requiring them to think critically, developing resilience and persistence in the face of difficulty. After working collaboratively and creatively, all critical 21st century skills needed for STEM jobs. But does it engage students to do more STEM? Yes. 76% said that Arduino-based projects made STEM more interesting to them. 59% said that learning about it increased their knowledge of STEM. 72% said that using it increased their self-confidence in solving STEM problems. Open source hardware and software are providing new and cost-effective ways to transform any kid into a maker by challenging them to create uses for technology that matters in the world around them. Arduino is one way for students to experience the thrill of making their idea from concept to prototype, providing the missing link that inspired so many Sputnik era scientists and engineers, the excitement of becoming a maker. Thank you.